for allowing us to be here, Doctor, and appreciate your expertise testimony, and thank you for your patience.
It's a pleasure to be here, and it's a privilege, and I hope that my experience in oil and gas and water resources here in the state of Ohio, where I've spent most of my life, will be of value. I've been an instructor or professor here at Youngstown State University for 20 years now. I own sizable, my wife and I own sizable property down in Columbiana County. We have a great interest in what's going on with the drilling activity here in Ohio with the Utica Shale. We have a well pad being sited within 3/4 mile of our house. And so we do have an interest in this. What I'd like to do is perhaps add to a little bit of what's been discussed already. There will be a little bit of repetition because both Mr. Stewart and Professor Chase are very knowledgeable and provided us with a lot of information. The state of Ohio has a long and robust history of oil and gas production. Beginning with the first well in 1860 and continuing to the present, Ohio has had more than 75,000 oil and gas wells drilled. Of these wells, approximately 65,000 are still producing. The majority of the producing wells are located in eastern Ohio. Ohio's production numbers are impressive, with approximately 1.13 billion barrels of oil and 8.35 trillion cubic feet of natural gas produced. Natural gas and oil are produced in Ohio today from about a dozen producing horizons, with sedimentary rocks that underlie the surface. These traditional reservoir rocks are predominantly sandstone, limestone, and dolomite. Over millions of years, oil and gas that was generated in organic, rich, shale source rocks gradually migrated and became trapped within these reservoirs. The predominant source rock in Ohio is the Utica Point Pleasant Interval, or it can also be referred to as combined formations. And for the ease of pronouncing the name of it, we just call it the Utica. The development of hydraulic fracturing in the 1950s, coupled with increasing energy costs and government drilling incentives, led to major production expansion in the 1970s here in Ohio with the Clinton Sandstone Formation. To this day, the Clinton Sandstone is the most widespread and prolific producing formation in the state of Ohio. The shale gas revolution that began with the Barnett Shale in Texas in the 1990s has arrived in Ohio and western Pennsylvania with the Utica Point Pleasant Interval and the Marcellus Shale. The Marcellus Shale in Pennsylvania has proven to be a major source of natural gas and liquids. The Utica Shale, in the early stages of exploration, and early results indicate potentially large natural gas and gas liquid reserves, and quite possibly a major oil-producing formation as well. Potential economic production from the Utica and Marcellus covers a vast region of eastern Ohio and western Pennsylvania. Reserve estimates for the Utica Shale in Ohio are as much as 5.5 billion barrels of oil and 15 trillion cubic feet of natural gas. And that's from the Ohio Department of Natural Resource study. The United States Geological Survey in 2011 estimates the Marcellus Shale to hold 3.4 billion barrels of natural gas liquids and 84 trillion cubic feet of natural gas. Production of oil and natural gas from shale formations is possible through the combination of directional drilling and hydraulic fracturing completion technologies. The drilling of long horizontal legs, which are typically greater than 4,000 feet in length, exposes a tremendous amount of the shale formation to the borehole. Production from the shale is stimulated by inducing fractures in the rock by hydraulic fracturing, or what has become known as fracking. Hydraulic fracturing in shale is controversial because it requires large quantities of water, thousands of tons of sand, and a variety of chemical additives. Conservation of water resources is a priority for Earth's environment and for its human population. The fate of the chemical additives that are pumped into the shale and later flow back as produced fluids is a major concern. Many citizens have raised legitimate questions and concerns about groundwater and surface water contamination by the chemical additives used in the hydraulic fracturing process. The production of oil and gas is naturally accompanied by brine water. Brine water is salt water that has more than 100,000 milligrams per liter of dissolved solids. It makes ocean water look like tap water. The state of Ohio has a long-established and well-regulated network of Class II injection wells to handle the disposal of production brine. Class II injection is the best management practice for disposal of production fluids. The Ohio Department of Natural Resources Division of Oil and Gas was granted primacy of permitting and regulating Class II injection from the U.S. EPA in 1983. Today, Ohio has approximately 176 Class II injection wells, or maybe it's 181, in operation. These wells are located primarily in eastern Ohio, although they are scattered about the state. Most of them are in eastern Ohio, where the majority of oil and gas production takes place. You have the injection wells close to where they're needed, where the oil and gas production is taking place. Development of the Marcellus Shale in Pennsylvania and the expectation of Utica Shale development in Ohio have placed an added strain on disposal capacity of Ohio's existing Class II injection wells. Injection wells have operated in Ohio since the 1950s. The majority of Class II wells in Ohio inject into common oil and gas producing formations, like the Berea Sandstone, the Clinton Sandstone, the Queenston Formation. Strict regulations and oversight has resulted in safe operation of these wells with very little documented problems. In recent years, deeper formations like the Rome, the Mount Simon Sandstone, and even basal granite sands of the Precambrian rocks have become target horizons for Class II injection. Earthquakes in Ohio are not uncommon. Since 1983, and I picked this date because this is when Class II injection in Ohio was granted primacy, the Ohio Seismic Network and the USGS have recorded 141 earthquakes in Ohio. These earthquakes are, for the most part, minor, having magnitude values in the range of 2 to 3. These earthquakes are generally felt only by people living very close to the epicenter, and they produce no significant damage to surface structures. Although actual depth information is sparse, the epicenters of the earthquakes generally correspond to known fault structures in the Precambrian basement rocks. Prominent structures are the East Continental Rift Basin of western Ohio, the Rome Trough of southern and southeastern Ohio, of which Marietta is close to, the Granville Front tectonic zone of western Ohio, a likely fault system underlying Lake Erie and paralleling the Ohio Lake Erie shoreline. Being offshore, it's difficult to map. Added problem. The Granville province of eastern Ohio, that's where we are, is marked by relative absence of earthquake activity. A legitimate concern of many Ohio residents and citizens of the broader region is whether or not injection activities of the North Star No. 10 injection well located on the west side of Youngstown is triggering earthquakes along a previously unknown fault within the Precambrian basement rocks. Records indicate the well commenced receiving injection fluids in December of 2010, beginning on March 17, 2011, and continuing right through to December 31st. A series of 11 earthquakes were recorded in close proximity to the injection well. The coincidence of timing and proximity of the earthquakes to the injection well raised public awareness and prompted the installation of 4 field seismographs on December 1st, 2011.